Hello, everybody. Welcome. Welcome to the June OWASP Toronto chapter meetup. We have with us myself, so Ophelia Chan. I have been part of the leadership team for the OWASP Toronto chapter for a bit now. We have Matt, who's on the team as well, and we have our guest speaker, Magno. He's back. Last time we had you on online here, we was I think around December time when you came to talk to us about software composition analysis. So that was
Mm-hmm.
a great session. So we're
Yeah,
super excited to have you back. Let's give everybody on the channels about 5 minutes to like trickle in, and in the meantime we can chat about what you've been doing lately. Anything that you've been following in the news, things like that. You want to take it
sure.
away and tell us about what you've been doing lately?
Sounds good. Yeah. So yeah, thanks for having me again here. Uh, that means that at least the first talk was good. So let's hope that this one is good too. Um, but yeah, my name is Magno. I've been in application security for over 10 years now. I'm currently at Trend Micro here in Canada and based in Ottawa, and doing research around cloud, container, and open source security technologies. Today we're going to talk about GitHub Actions and what has been kind of the results of my research that I did at the end of the last year and published early this year, and also have a new article coming up in a couple weeks. And
Nice.
so I brought a new things, new interesting stuff for the meeting today. So yeah, you guys are in for a treat. Stuff that haven't been published yet that should be coming up in a few weeks. So
Nice.
yeah,
Very
that's
exciting.
mhm, mhm.
Yeah.
So you said you worked in was it cloud and open source specifically, right?
Cloud and container security. That's kind of
Cloud.
the main focus of our team. So anything related to different cloud providers and different services around the three major providers or even other CSPs as well.
Mm-hmm.
But my focus specifically has been on containers and Kubernetes. So the past 2 years, I did a lot
Oh,
of research around Kubernetes
yep.
security, and nowadays I'm focusing on other cloud native tools and also some open source projects.
I say I don't mean to like put you like too much on the spot here, but in terms of like Kubernetes has like a lot of like interesting quirks associated with it.
Mhm.
I think a lot of people, especially from like a self-managing perspective, like making sure everything is updated and
Mhm.
like that can be quite a chore.
Yeah.
So I'm kind of curious from like your perspective, like what are some like common things you see with Kubernetes and like container security that like someone could easily just improve like tomorrow?
Mhm. Okay, so yeah, I think that it's like the assumption, even with the managed services, right? So
Mhm.
there are some security considerations that you need to be aware of.
Mhm.
But yeah, three things I think just to start. Kubernetes is very complex and it's hard to understand all the ins and outs and all the minor components of how everything works. So it takes time. Don't worry and don't feel like afraid, because it's gonna take some time to learn. Even if you have already the basics of Linux, containers, and networking and all that stuff, you still need to understand how everything connects into Kubernetes. But yeah, three main things there from a security perspective that you need to look at. It's like there are at least three APIs that are exposed, that can be exposed via Kubernetes. So you have the main Kubernetes Kube API server. That's usually the one that you see more out there. But there's also two other APIs that are usually only local, the kubelet API and the etcd API. And I'll talk about those in a second. So the kubelet
Nice.
is the agent that runs on each node, each virtual machine, each host of your cluster. We
Mhm.
call them worker nodes. And the etcd is the key value store, right? So there, all the configuration of Kubernetes, your storage, it's where it's saved. Everything from your objects, your secrets, all the Kubernetes API objects is stored there. So there are free APIs there, and you need to be aware of those. So um, I just recently published. Let me see if I find the link here. An
Magda,
article.
I do have to say, by the way, you're a wealth of knowledge. You know that, right?
Although
Uh,
with that kind of scope in terms of like your actual day job, it's it doesn't cover anything at all, of course. Like all the clouds and all the containerization.
Exactly. Yeah. So
Holy
so
crap.
it's hard to sometimes like focus too much on one thing without going too deep.
Yeah, of course.
But for example, right, we found some kubelet APIs exposed on the internet, especially on Shodan and other kind of search tools there. And we were able to query those APIs and find information about the name of the containers, the number of pods that were running, some kind of sensitive information that might reveal who does this cluster belong to, so which company. And so that can be also kind of scary, right? So from someone that's just starting, that gets exposed, that can give a lot of information from an attacker to compromise your environment, right?
Mm-hmm.
Absolutely.
Yeah. The second thing about Kubernetes is RBAC, role-based access control, right? That can be very tricky, and it's easy to get it wrong. There is a lot of great research out there on how to perform proper configuration on RBAC, right? So even applying the least privilege principle, right? Making sure that your users or your service accounts on Kubernetes have only the necessary permissions. So that can be very tricky. And I think the third thing would be with etcd, which is your kind of storage unit there for your cluster. You can change if you want MySQL or anything, but that's the default one. First thing, it's not encrypted by default. So you have all this information about your cluster, which is in plain text. And so if someone has access to that storage, and they can change information there, right? So anything that's inside that storage, it's reflected on your cluster. So for example, if I change one image and I add a new container there with my malicious image, then the cluster will deploy that because it's part of the concept of the desired state of Kubernetes. So we'll try to replicate that as well. And also because it doesn't have encryption by default, Kubernetes has some objects called Kubernetes secrets. But since they're not encrypted by default on etcd, and also they're not protected because they're only base 64 encoded. So those secrets, if anyone has access to those, they can quickly decode and have access to tokens or passwords or any sensitive information that might lead to a privilege escalation inside the cluster or even a container breakout.
Oh yeah, containers are pretty devastating.
Yeah, exactly.
So Magno, I'm kind of curious. Like you talk a lot about Kubernetes, open source security, stuff like that. How did you even like get into it in the first place? It's kind of like a very complex thing. Where do people go to learn like initially about these kind of technologies?
Sure. Yeah, I can talk about Kubernetes all day.
Apparently,
I feel like we're getting a 2-for-1 here. Like we're getting like a mini lightning talk about Kubernetes, and then we'll
it's good. It's good. We like it. Yeah.
Sure. No problem. Yeah. But basically, when I joined Trend Micro over 2 years ago, around January 2020, I joined to my first kind of task there. My main task in the beginning was to help them with the container security scanning solution that they had, and to help maintain kind of the vulnerability feed to generate all those CVE and vulnerability informations from different security advisories, and keep that up to date. But our product, the product for the container scanning, used Kubernetes, so it was running inside a Kubernetes cluster. And I didn't know anything about Kubernetes at the time, just that it was a container orchestration tool, and that's it. I had a little bit of knowledge of Docker, but I wouldn't say that I was an expert there. But so I had to learn, right? So if I need to deploy a cluster to test my feed, my vulnerability feed and everything, and something's not working, there is a pod that's in crash loop back off or giving some errors, and I had to debug. So it took a lot of time. Sometimes I had like a snapshot of my testing VM, and something goes wrong. I just reverted back the snapshot, and I said, okay, this is not working, right? I need to learn this stuff. So that's when I took some training around just kind of using Kubernetes and understanding that, watched some talks, and even created like a repository of Kubernetes information on GitHub. I have that as well here. Let me.
Dude, you got this all on hand. You're amazingly prepared.
Yeah. Let's see. Awesome Kubernetes security. So this is kind of the GitHub project, because I was there. There was information all over the place, right, for Kubernetes. So there wasn't okay. Where is the one place that I can go to learn about Kubernetes and Kubernetes security? So I was saving all those links and all blogs and books and all that stuff in kind of a text file for myself. But I said, why don't I share that with the community, right? So after a few months, I think was in October 2020, that's when I launched this project on GitHub, the awesome Kubernetes security list, right? We have some other awesome lists on GitHub with a lot of kind of interesting links. So I created this one there on GitHub, and there is a lot of information on how to start. You need to know the basics. You need to know how Kubernetes works before you can get into the security of Kubernetes. So you need to know that. And yeah, that's what I got from there. After I finished kind of this project helping the container scanning solution, during the pandemic, I was invited to join this container cloud and container security research team. And I decided, okay, I'll apply what I learned about Kubernetes and now focus more on the security aspects of it and start doing more research around, okay, what are the problems, what are the defaults, what kind of managed services, how do they differ from the default Kubernetes installation, the self-managed, right? And I published a few articles around, okay, just the basics of Kubernetes security.
Nice. Yeah,
Awesome.
I remember reading some of those early, like as well, when I was trying to get up to speed on some of the things where it's just like I'm not going to have time to do all the research. I wonder what my friends are saying about it. So, yeah,
Yeah, there is
thanks.
a lot of great research out
There
there.
is.
A lot of people that are really focused and really deep technical in Kubernetes. But sometimes kind of, okay, where do I start, right? Where are the main things that I should focus on, or should I recommend for my organization or my customer? Sometimes that can be tricky, right? So
Absolutely.
I decided to focus more on kind of the basics, I call the Kubernetes Security 101. But yeah, at least that's something that people might benefit from.
Yep. Based
Hey
on
everyone. Sorry, was just listening in. Hey Magno, welcome back.
Yeah.
I'm quite a bit late here, but yeah, I agree with what you're saying. I'm pretty much not an expert in Kubernetes, but something that I'm gonna find value in. Of course, considering that that's not ideal with on a day-to-day basis. So I think you're doing great work, and can't wait to listen to your presentation today.
Awesome. Thank you.
Yeah, we have gone on for quite a bit, so thanks for that whole lightning talk.
Sorry. Yeah. I
No,
can
it's
talk
good.
all day, but yeah.
That's like
We
a
should
separate podcast that we
should
have, two
totally
in
invite
one.
you back for that.
Oh,
Yeah.
yeah.
Sure, no problem.
I
Yeah.
did want to like a couple of housekeeping notes before we like hand it over to you, so that you get like you get to actually talk about your actual talk. So thank you everybody for coming. We're just gonna get started. But if you do want CP credits, or you want to provide us with feedback and things like that, you can check the description of this particular video and send us feedback through the forum. So that's there in case you're interested. We are reviewing the forums on a pretty regular basis right now. I mean, there's not that much to do, but we're trying to decide like when we can go back to in-person things, and what we should do for them, and so on and so forth. So we're really looking forward to seeing if you guys have any feedback. And then for CPE credits or whatever, you still need to, put your CPE credits through your regular whatever portal you're using. But if the auditors come and say like, hey, did this person show up to a thing? We need your name and your email address in some kind of form to be able to say, yeah, that person was here. So that's all for me. I'm going to hand it all back over to Magno now, and you can take it away. Thank you.
Sure. Sounds good. Thank you. Okay. Just move my screen here. Okay. Can everyone see my screen? I guess so. Okay, yeah. So yeah, the topic today is not about Kubernetes, right? It's about GitHub Actions. But if you have questions around Kubernetes or this talk today, feel free to post them on the YouTube chat, or feel free to reach out to me anytime. I'm happy to discuss more about this. Yeah, this talk is GitHub Actions, protecting your CI from attackers. We're gonna understand a little bit about what is GitHub Actions if you haven't heard about it before. It's a fairly new service that was published in 2019 by GitHub, and how you can leverage that to automate your CI, right? Your continuous integration pipeline, doing some automation and building. And you can also leverage that for triggering security scanners, right? SAST, DAST, or SCA scanners, right? The last talk that I presented here was about software composition analysis. So you can do that with GitHub Actions as well. But we're going to talk about that from a security perspective, right? So focusing on what are kind of the problems, and this is based on the research that I did. I started last year, and it's kind of ongoing. I go back and forth to this topic, and I published an article last year in in January. Let me grab the link here real quick. Let's see. Okay. So basically, yeah, we're gonna talk about the research that I did, the results that I found, and some interesting information about GitHub Actions, and especially if you're already using or thinking about using GitHub Actions, some of the things that to be aware when leveraging this kind of SaaS service, right? A CI as a service there from GitHub. And just an interesting note about this topic, and I forgot to mention before when we were just talking about Kubernetes and stuff. This talk got accepted at Sector, so I'll be presenting kind of maybe a newer version, but a little bit similar to this in Toronto in October in person. And yeah, I think there was 2 previous events that I presented this already, but I'll bring some new information today. As I mentioned, there are an article that's coming up in a couple weeks, 2 to 3 weeks, still this month, on some new things around this research, and focusing on how attackers are kind of leveraging that service to abuse that and to mine cryptocurrencies most of the time. So we're gonna talk about some of the stuff already here. Yeah, so just a little bit about myself. I've already introduced, but if you weren't here, I'm an information security specialist and senior researcher at Trend Micro in Canada. We have some positions available for Toronto and Ottawa as well. So if you find an interesting role there on the website that's kind of appealing to you, just if you want to know more, just reach out to me. I'm happy to talk about those and kind of point you in the right direction, talk to the hiring manager or whatever. I'm pretty open about that. And I'm part of the cloud and container security research team. So it's always still part of what we call the Trend Micro research, right? But we have some specific areas of focus there, and most of the time it's cloud and container for us. So that's why. I've been in AppSec, application security, for over 10 years now, doing everything from pen testing, web application security assessment, code reviews, web application firewall management, and all those things. So I'm pretty familiar with the industry and everything related to AppSec and DevSecOps. And I have a personal blog there, katanasec.com, which I haven't been updating for a while, but at least has some information on my previous talks and how to contact me as well. So I'll leave that here. But yeah, as you can see, I usually talk a lot, so feel free to ask questions during the presentation. I'll try to look at the chat and make sure, taking some pauses there, make sure that everyone is understanding and up to speed on everything. But this is our agenda for today. So basically, I'm going to give an overview about GitHub Actions. how it works, how you can implement that. You can start right away. It's a free service from GitHub. If you're already using GitHub repositories, right, to store your code, which most of us are, so you can leverage that right away. It's free. There are some known vulnerabilities or known security issues already. Even the GitHub team published a couple of blogs, a series of blogs, I think 3-part blogs on kind of the main issues that they found, and they, some of them they fixed already, and they mitigated on this service. I'll talk about some attempted attacks. So what I did during my research, what I try to kind of leverage while I was testing my own GitHub Action service, and at the end, just provide a few guidelines or countermeasures, best practices that you can find directly on your GitHub settings to enable that and avoid some of these attacks and some of these problems already. So yeah, this is the article that I shared on the chat there. Just special thanks to Alfredo Oliveira, which is the tech lead for my team and helped me on this research. Right, he's part of Trend Micro too. He's based out of Toronto. So yeah, just thanks again to him to help me on this. Okay, let's start with understanding what GitHub Actions is. You've probably heard about Jenkins, or maybe what other CIs are out there. Let's see. There is, I think, Code Pipeline. There is Azure DevOps. GitLab has their own CI too, right? So there's many other software CI platforms that are out there. So GitHub Actions is the kind of CI service from GitHub, and it was announced, I think, 2019. So very kind of 3 years ago, and it's basically a way for you to create your own pipelines using GitHub and using YAML files, right? You can specify all the steps of your pipeline and run different what we call jobs or different actions. Everything, it's running on GitHub, which technically runs on Azure, right? Because GitHub is now owned by Microsoft, so we're gonna notice some things related to Azure here. And all you have to do is create a YAML file and put that on your .github/workflows directory. And if that's that's following the kind of the standards for the GitHub Action pipeline, then any event, it's gonna trigger some of these actions, right? And an event can be any changes to the repo, can be a pull request, can be anything. There are some set of events already available from the GitHub Actions that you can that the repository is gonna monitor for it, and if it sees that event on that repo, it's going to trigger your specified action or specified automation there. As I said, all these actions or workflows run on Azure, and GitHub provides you some what they call runners, which are basically VMs, right? Instances or VM virtual machines inside Azure to run your automation. And these machines are right now the ones provided by GitHub are Ubuntu, Windows, and even macOS environments. So that's really interesting thing, especially if you're doing development with macOS, which can be very tricky to kind of deploy those environments. So GitHub is providing those machines for you. One quick note here, those are VMs. I just want to highlight that. Those are not containers. So you can take a look at all the software that comes installed by default on those VMs on the GitHub itself. There is a repo there. I'll probably find the link later, but there is a repo with all the kind of different programming languages and different software, everything that you may need for your automation or for your build pipeline might come installed already. And so that can be maybe a good thing if you don't want to install it every time, or maybe a bad thing. It can be a risk from a security perspective, right? If you don't trust that software and that's installed by default on your build environment. As I mentioned, it's a free service. It's kind of a free tier for GitHub free, and you have different versions for pro and team and enterprise plans. There are some limits, right? But usually it's like unless you're really doing a lot of stuff, a lot of automation with GitHub Actions, you're not gonna reach those limits, at least from my perspective. But yeah, you might run into that, so you might need to upgrade your plan or require more kind of increase your limits for your GitHub Actions, right? Okay. So basically, that's how you have your workflow or your action set up, right? You have an event, right? Something happens. As I said, can be a pull request or any changes, a push event to the repo, and that triggers an automation, right? That automation first deploys a runner, and that runner is a server that's going to run your automation. And here, for example, we have two runners, right? We have runner 1 and runner 2, and each of them are running different jobs. Runner 1 is running job 1, and runner 2 is job 2. And inside those jobs, you have a series of steps, like a series of commands that you can run. I don't know, download a package, install something. Each of these actions, each of these steps can be an action inside your runner. And also, one interesting thing that we're going to see right in the next slide, is that my action can call other actions. So, for example, similar to what we have with the Jenkins plugins, right? Here you can have third-party GitHub Actions that you can call from your own environment, your own automation, so you don't need to reinvent the wheel. And I think that's what made GitHub Actions very famous very quickly, because you have the marketplace on GitHub Actions. And I'll just quickly move another slide. Okay, you have the marketplace on GitHub. There are, I think I forgot to update the slide, but I just noticed today there are over 13,000 extensions available for GitHub Actions on their marketplace, and anyone can publish your own action, right? So if I wanted to write my automation and publish that for other companies or other GitHub users to use, I can do that, right? So anyone can do that. It's not like the App Store for Android or iOS, that you have to pay something and then you can publish your app and then it takes a while. No, right? If I want to publish something, it's like there, I can publish right away. And then you have to trust whoever is writing those actions to see if you want to use that on your own environment, right? Of course, you can see the code because all those actions are published as public repositories in GitHub as well. But like, do you have the expertise and the tools necessary to do that, right? As I mentioned, you can use the actions for different things. Since we're talking about security here, you can leverage GitHub Actions to perform automated DAS scans, right? Dynamic security testing, software composition analysis that I showed in the previous talk in December. Code analysis, you can use static analysis tools, even the one from GitHub, which is the CodeQL, right? The CodeQL for static analysis for different languages. So you can run that as well, and that runs as a GitHub action. And there are many other things that you can do with that. It's a CI solution, so think about pretty much anything that you can do with a CI tool, you probably can do with GitHub Actions. Okay, any questions so far? Let's see. Let me look at the chat. Sorry. Okay. Yeah, I think someone.
The one question that did come up, you already answered, I think.
Okay.
was
Is there an
around.
image for GitHub official runner? Yeah, someone posted the link there, I think, right? The
Yep.
GitHub Action environments. Yeah, that's the one.
Yep.
Exactly. So there is it's not an image, as I said, like it's a VM. And they build, that's one interesting thing, like that I'm probably gonna talk about later. But like, yeah, that's one thing that I found in the, sorry, maybe just my power running out. During my research, is that I thought it was containers, right? I thought it was containers because it was running so fast. I was playing around with it, and I changed some actions, and basically, oh, it's done, right? It was really fast, and I said, okay, what's going on here? But these are VMs, these are virtual environments, and the way that they work, at least from what I could see and what I could understand, is that they have those VMs ready and idle, in a kind of idle state for you, just waiting for jobs to kind of, okay, yeah, I need a VM, a Ubuntu VM to run this job, and then they provide it for you because it's very quick, it's very fast, and it takes less time than deploying a instance on any cloud provider. So that's why, like, okay, first I thought it was containers, but then, yeah, reading the documentation and of course during my testing, I okay, this is not containers. So yeah. Okay, let me go back so we don't drift too much. Here's kind of an action, just an example, right? This is running the DAS scan with nuclei or nuclei, however you want to pronounce it. So this is kind of the YAML file that has to be inside this specific directory, right? So it has to be .github/workflows, not workflow. It has to be workflows. So if you forget the S and you add the YAML file there, nothing's gonna happen. So trust me, I made that mistake already. So that's why I'm just kind of emphasizing that here. But yeah, git.github/workflows, and then it can be one single YAML file or multiple YAML files, whatever you have there, and they're going to run based on the events that are triggered. So on this one that I have here, the nuclei scan, right? This one is running. It can run on a specific schedule, right? Based on the cron tab here. So I can define that. So it's gonna run periodically, and then it's running also on they call workflow dispatch, and this means that I can trigger this workflow manually, like whenever I want, right? So it's like, okay, I have periodical scans running and targeting a specific application, or I can trigger that scan on demand, right? So this is basically what's on the on and schedule and workflow dispatch. And here I have one job called nuclei-scan, right? And this job has multiple steps, and it's runs like this directive here runs on Ubuntu latest, right? This means that I'm using a GitHub action runner or VM server from GitHub, right? The Ubuntu one, the latest version of the Ubuntu one, to run this automation, right? So I'm gonna grab one virtual machine that's available for me on Azure to run my GitHub action, and then run all this automation, all these steps that are here. Basically, we have 4 steps. The first step, we have like the uses directive here, and it's using actions/checkout at v2. What's going on here? We're calling another action from someone else, right? In this case, it's from GitHub because they own this organization or this repo, actions/checkout, right? So if you want to see the code that's being executed when I call this step uses action/checkout at v2, I can go to github.com actions/checkout, and I'll find that code, right? So if I go here, let me type, I'll post the link there directly, but let me just type here checkout that. So yeah, if I go to that link, I can see the versions, the releases of the version 2 of this actions slash checkout, right? So as I mentioned, any other action that's published in the marketplace, they are inside a public repo. And you can easily find those. Just going github.com, whatever name is here, github.com/ and then actions slash checkout. You don't need to add the at because that's the version there. You can find it on the releases. Okay, so this is calling a third-party action. So I would have to go to this third-party action to know what's going on, what is it doing, right? But since I know already, this action basically what it does, it's downloading the code from my repo inside the VM, inside the runner, the GitHub action runner, right? So it's a pretty standard action that a lot of people use. So that's why GitHub created and they maintain it, right? Moving on, the second step here, there is the name nuclei dash scan. That's also using another action. That's using the project discovery slash nuclei dash action at main, right? So now I'm calling another third-party action, right, from project discovery, right? So if I go again to github.com slash project discovery slash nuclei dash action, I'm going to find that code that's running when this step is executed, right? And I can see there are some parameters here. There is one parameter with target, right, example.com. So here from this action, there is this parameter that I'm specifying, which is basically the target of my application, the target of my scan, right? The next step is the GitHub workflow artifacts, another third-party action calling this action slash slash upload artifacts. And this is basically once my this basically means because once my my pipeline, my action is completed, my VM is destroyed. I don't have access to it anymore. So any files, any logs or outputs that were generated inside that VM, if I don't upload it somewhere, I lose it, right? So what I'm using here, it's another action from GitHub because they own this actions organization there or user. And this action is to grab the results, the nuclei logs from my scan and upload inside my repository so that I can download from the GitHub UI, the GitHub interface, right? Otherwise, it wouldn't matter because the scan is done and I wouldn't have access to the logs. So that's not good. And also the last step, just as an information here, right? Another thing is I'm uploading some alerts in a format called Serif, which is a format, if I'm not mistaken, created by Microsoft to kind of try to standardize the output of static analysis tools. And this is just using another GitHub action from GitHub slash codeql action slash upload serif, right? So you can find the code for this action on that specific place as well, right? So just an understanding, right? So we have the name of the action, we have the events that trigger that on, we have the jobs running. I could have many different jobs. I have the runner, right, on the runs, ons directive, and I have different steps. Here, I don't have any commands, but I can also run some commands directly on the server. And if we have time at the end, I can demo that directly on one kind of testing repo that I have. But yeah, there's a lot of things to do here, and you can use to automate, probably create your CI pipeline just using GitHub Actions. So I find very interesting to use, especially if you're leveraging GitHub for your repos already. You don't need to maintain another server or Jenkins, or you pay for whatever service for Azure DevOps or AWS code build or code pipeline to run your automations. If you can leverage GitHub Actions, right? This is my kind of introduction so far. Now we're gonna move into the security stuff. Any questions so far? Okay, looks no questions on YouTube. Okay,
Yeah,
I'll,
nothing so far. Thanks.
okay, sounds good. I'll start. Yeah, I'll keep moving forward. Okay, so here are some of the right. And when I started my research on this topic, is like first thing that you want to know is like what's out there, right? What people have research on already and published around this topic of GitHub Actions and GitHub Action Security. And there were 3 great blogs from GitHub security team themselves, and they are all listed at the end of the references, and some are on the slides already. But basically, okay, some of these are kind of the main issues that I saw, and that they reported as well. First thing was pull requests from forked repos, or AKA pound requests. What does that mean? It means that right in the beginning of the GitHub Actions, there was a vulnerability where if I forked your repo, for example, any repo that you have, and I made a pull request back to your repo, if I made any changes and I made a pull request back to your repo, I was able to trigger my own actions in your repo. So we're going to see in the next slide here that what attackers were doing, they were forking many different repos that had the GitHub Actions enabled, and they were sending pull requests to trigger the GitHub Actions on kind of on the other users, the main users' behalf, and doing that to basically mine cryptocurrencies. That's kind of I think that's kind of fixed now, at least this kind of approach to mine cryptocurrency via forking and sending pull requests. There are some settings as well that GitHub implemented that you can enable or disable GitHub Actions if you're not using it. So we're gonna see that at the end. But also there are many other ways I think that users still leveraging to mine cryptocurrencies. That's usually the end goal that I saw, but we're going to talk about that in a second. Another problem that also GitHub reported there is command injection via untrusted inputs, right? So there are some fields that are used from your kind of your issue and your automation there that can contain malicious input. So depending on the name of the hey, sorry, my dog. Depending on the name there on the specific fields, you shouldn't trust those. You should validate those inputs, and we're gonna see that as well, the list of some of those fields. And the third point, that's basically where I focus more on my research on, and that's basically where I talk about the article that was published in January 18th, where I talk about malicious GitHub actions from the marketplace, right? If we have this marketplace and anyone can publish that to any actions to the marketplace, would myself as an attacker, would I be able to trick someone into using my malicious GitHub action, right, into the marketplace? So that's kind of I did as a research, and of course, no repositories were compromised, but we proved the point here that we were able to do that and kind of inject an action as a backdoor into someone else's environment. Okay, so here's an example. Here's some, there was a tweet that came, I think this is to 2019, early 2020. Someone tweeted about this. Oh, my repo just got hit with a similar attack, right? Someone was, they took a screenshot of this user on GitHub that they opened like 99 pull requests on 95 different repositories. So that's basically what they found. They found that they were able to run their own actions, their own specific actions on behalf of other users. So Of course, these VMs, the runners from the GitHub Actions, as I said, it's running on Azure, right? But basically, you have your user like linked to it, right? So if you're abusing those services, your user probably is going to get probably gonna get a message from GitHub, or they're going to disable the GitHub Actions on your repository, right? So even if you're not the one doing bad things, you need to be aware of those. So here's an example on the right side of an action that's kind of mining cryptocurrencies, right? The idea here that they're running on a schedule, and there is also a watch event that they run on, and they basically has this one job running on the Ubuntu latest as well. And you can see here that it's checking if the repository owner is the sender ID. This is basically what's checking. So if the owner of the repo is the same of the sender ID here, and then it's start some steps here. Uses action checkout. Remember that the same one that we showed on the nuclei dascan. This basically downloads the code from the repo inside the VM that's running the action. And here we have some interesting stuff. So you can see that's running kind of a wget command to get download the xmrig binary Linux, right? Because we're running on Ubuntu latest, and then it's untarring it, right? Just decompressing, extracting all the information there, and then basically downloading some other configurations from Google Rime. It's a Python script, and then starting the xmrig, right? The binary xmrig, starting that, and at the end there was one more step that it's like, okay, if failure, right? If failure, then sleep 99 days, right? So basically, you want this VM to kind of never stop and keep running, because right, the more you have your crypto miner running, the more money the attacker would get. And there are many other examples. I'm gonna show more here, but there are some limits here. And as I said, this problem was fixed, at least from the forked repos, was fixed by GitHub already. You can see more information on the link to the blog, their blog, security blog there on the slide. But there's still many other attempts or kind of different scripts trying to mine cryptocurrencies leveraging GitHub Action, right? Because it's like, even if I mine cryptocurrencies with my own user, I'm not paying anything, right? Who's paying for that server? Who's paying for that compute instance? GitHub and Microsoft or Azure, right? So we're gonna see that attackers started kind of shifting their way into trying different approaches to mine cryptocurrencies. But this was kind of the early stages, and this is what they did. But usually you can mine, right? This, sorry, is that a question?
I was saying, yeah, I think you answered the question, but Costa asked, does pull requests refer specifically to self-hosted GitHub action runners, or was this also working on the Microsoft runners? And I think you kind of inadvertently answered that one, but
Yeah, that's the Microsoft runners and not the self-hosted.
okay, thanks.
Yeah. Exactly. Okay. Yeah, most of the time they're mainly they're mining Monero, so you can see a lot of xmrig and all that stuff. Yeah. Okay. But then this is already the content for my next blog post that's coming up in a couple weeks. But I'm bringing this information exclusively for you guys here for OWASP Toronto. So, and I'm probably going to present that at Sector as well. So I started kind of lately. Okay, how many scripts that are leveraging crypto miners or cryptocurrency automation that are using GitHub Actions, right? So I start researching on that and finding many different YAML scripts and analyzing those to understand what they're doing. So this one that was interesting, that caught my attention. This one is using the Windows latest, so it's using the Windows runner, and it's automated to run on push and pull requests. So basically, any kind of changes to the repo, and the name says CI/CD, right? CI/CD. There is some stuff that I haven't figured out yet. Why is that here? I think it's to this matrix. It's to trigger many different runners on different versions, if I'm not mistaken. So the matrix here with the go and flag, it's like, oh, run on try version 1.1, version 1.2, and but you don't have versions, right? You don't have software versions. So it's basically to kind of parallelize your crypto mining attempt, but that may kind of increase the risk of the mining being flagged and being detected either by the user or by GitHub security team as well. And yeah, they are leveraging crypto third-party actions. So they're using the checkout action, right? The actions/checkout. They're using this kind of sad path step here, the second step, sad path. It's basically calling another third-party action from a random user called Nick Envision, and it's using the retry, right? So it's like attackers are already leveraging third-party actions, so they're kind of ahead of us in a lot of things. But yeah, that was something that caught my attention, and I'll show the link to this third-party action in a minute. But basically, what it does, right? It's retrying your actions if it fails. So basically, if their mining script doesn't work, it's going to retry again after some timeout. So these are the parameters: the timeout in minutes, max attempts, and the retry wait seconds are just parameters on how often they're going to retry and run this action again if it fails. And basically the command is a node.exe file binary, right? xmrig, and then it's specifying the pool and the user information, right? So and I've collected a lot of those. That's probably gonna come out on the next article that I mentioned. A list of pools and also users that are kind of have this script in GitHub Actions YAML files. I don't see a legitimate reason for you to have this script, right? Cryptocurrency mining, it's a legitimate thing to do, but not specifically leveraging GitHub Actions and using GitHub owned runners, right? So that's why I talk about this in the article. So yeah, I went to find out the code for this Nick-envision/retry third-party action because this was the first time that I saw it. So yeah, I basically went to this repo, which redirected me to this Nick fields/retry. And then I understood, okay, what this action was for. And it's a legitimate action. It's not a malicious one. It's for retrying action steps on failure or timeout, right? But the attackers were doing that to automate their mining scripts, right? So that was kind of interesting for me. I'm not sure, but yeah. So some legitimate GitHub third-party actions are being used for attacks. And also, if you notice the node.exe xmrig at the end, the last command there at the bottom, I was able to download this binary because it was on this repo that I found. I won't share this link, but there are some links there that I'll share later. And yeah, just analyzing this node.exe on VirusTotal, yeah, major percentage of the antivirus detected as malicious, right? Crypto miner XMRig. So it's not a node. So if you see the binary, they're kind of changing the name of the binary to a node.exe, but it's not a node. It's like a XMRig crypto miner, right? Okay. Moving on. Basically, there was another one, and this one I saw a lot. They're still out there. Another crypto miner using Windows runners and now using PowerShell. There are some commands down there that you can see that are PowerShell related, invoke web request, expand archive, and all that stuff. So that was interesting as well. Different pool for miners and different users as well. The dash U here at the XMRig at the bottom is a different user. But I also found multiple repositories from different GitHub users using the same user for the crypto mining, right? So probably means that they are related, or at least someone is using the same user because they're gonna go to the same wallet, the results for that crypto mining. So that was interesting. And same approach using the parallel here with the matrix to kind of automate those. And you can see that in the matrix here, there's something interesting. In the Go array, you see 1.0, 1.1, 1.2, 1.3, and then there is 1, and then there is comma 35. I'm not sure if that's a typo, but the same script exactly with the same typo, I found it on many other different repositories, different users. So it's like, I'm not sure if that's a typo. Is everyone just copying the same typo and whatever is going on? I'm not sure about that, but it's kind of, it caught my attention, right? So maybe it's one dot should be 1.35 and they mistaken the dot for the comma or something like that. But yeah, here's basically a list of all this, and there's more, there's much more, but this is just a sample list of all these YAML files, different repositories with different users that are running exactly the same script. This script here they call Captain Crypto. So yeah, but it's basically a Monero XMRig crypto miner. Yeah, there's also attackers abusing the Linux runners, right? I showed one example at the beginning with the pound request, but there's still some that are using that to yeah, of course. And I thought, like, in the beginning, I'm a very, I would say, very newbie person on crypto mining. And I asked a few friends that are in this field already, like, okay, is there a difference in using Ubuntu, Linux, and Windows? And that might sound like a dumb question, but I asked anyway. And I know that, oh yeah, is it better mining on Linux because it doesn't have a lot of other kind of programs running or crapware or whatever that's installed, and it might leverage the memory and CPU better? I don't know. But using the Windows runners, I haven't found an explanation on why would someone use the GitHub Actions Windows instead of Ubuntu or Linux ones. So if anyone can answer that for me, that would be great. That's my question for the audience there. But yeah, similar approach, downloading the crypto miner, right? They have access to download stuff and run different commands on their runner. So they're downloading that and running the miner. And this one, yeah, just kind of specifying the pool and the user and running the miner itself. And it's not very concealing of what it's doing, right? It's saying, oh, let's mine, running miner, and extracting XMRig. So some of them are not, they don't even care. They're not trying to conceal what they're doing. Some other scripts that I found on GitHub, they are trying to conceal what they're doing by changing the name of the binary, and some of them are also limiting the percentage of CPU that they're using from that runner. So for example, you know that crypto mining uses a lot of processing, usually GPU, but in this case it doesn't have GPU, so it's using CPU for mining. And they were kind of limiting the CPU percentage of the miner to 70%, so that it wouldn't reach 100% and it probably wouldn't get flagged or try to avoid some detections there. So some of the scripts that I found were also limiting that. And this is what happens if you try to run crypto mining on GitHub Actions. You get blocked, right? Your actions and your actions is going to be disabled in that repository, right? So basically, this is what GitHub is doing to prevent malicious or abuse from crypto mining in GitHub Actions. It's like you're going to see, if you go to the repository and there is a tab there called Actions. If you go to the repo and you see this alert, the red alert here on top, disabled for this repository, it's probably because they were abusing the GitHub Actions. And most of the time, the ones that I saw, it's because they were trying to mine cryptocurrencies, right? So if you see that alert, you probably did something wrong. They're not going to call GitHub support because they're usually malicious users. So yeah, they just blocked. But this is per repository, not per user, right? So if my this repository gets blocked, I create a new one, I can probably mine cryptocurrencies again, unless GitHub decides to block my whole user and from abuse case scenarios. But usually this one is per repository. We also, the Trend Micro research team, right? We also have a white paper published on more cloud-based crypto miners, not just GitHub Actions, but other services and how threat actors are using that. They have some references from some articles that I published last year around threat actors mining cryptocurrencies on Kubernetes clusters. One threat actor called Team TNT. So there is a reference to the article there as well. So I highly recommend you check that out, their white paper. There is a white paper there, and there's no kind of paywall or form to get the white paper. You can just click and download the PDF file if you want. But it's not about GitHub Actions. It's more around cloud. They call cloud-based crypto mining, right? Using those free SaaS services to mine cryptocurrencies for free, right? So yeah. Okay. Let's see. Yeah, okay. So yeah, Costa asked the first question here. Maybe the Windows runner has better specs than the Ubuntu runner. If I'm not mistaken, all the runners, at least Windows and Linux, they have the same specs. It's a DS V2 something. Yeah, it's like a Azure instance. So they have the same specs, memory and processing at least. Wait, are you saying that the forked repos has actions disabled, or that the mining repo that they're checking out is disabled? So in this case here that I showed on the previous slide, this is their own repo. The malicious script is inside that repo, and they try to run GitHub Actions in that same repo, right? This is different from the pawn request. This is something else. So they're using their own user and their own repository to run the actions and try to mine cryptocurrencies. And you can see that they are update main.yaml, pages, build, and deployment. And you can see the logs. I can show, if we have more time, I can do during the demo. I can show that we see those logs. And we see that they're not doing anything related to, they say what they're doing here. They're mining cryptocurrencies. And so the user repository that triggered the mining action that gets disabled. Okay, let's move on. I hope that I was clear there. So yeah, there is the event of command injection via untrusted inputs. That's an area that I haven't researched too much yet, but probably, yeah, a good topic to focus on more. There is an example here, and as I said, the security lab security team at GitHub published an article around that. And if you can notice that this is the first kind of piece of action here is different than the second one, right? So you see that there is a dollar sign at the beginning of the last command here, and this is basically triggering kind of a template injection, right? So it's evaluating this, and whatever it's in there, it can generate a template injection. So these are some of the or command injection, but these are kind of the fields there that you have. If you're using those fields for anything in your action, these can have malicious input, and you should probably validate those, right? Perform some allow listing validation before you use those on your automation. Okay. Yeah, and this is kind of the main topic of the research that I did, and it's around the malicious GitHub actions, right? I already covered this. Anyone can post actions on the marketplace. You have to treat these as kind of a third-party dependencies. So just like what you have for your software libraries, right? Your log4js or your spring4js, whatever, that can have vulnerabilities. You probably should take the same approach to evaluate and assess the risk on those third-party actions before you use those. One of the things that you can look for is that GitHub has some kind of badges. They call it the verified badge. So I'm not sure exactly how they give this badge, but if you're like an organization, a well-known, and you publish something and that you want to be kind of verified by GitHub, you get this badge on your action. So you say, oh, creator verified by GitHub. I'm not sure what that means, because it probably doesn't mean that they're doing some security scanning on the action itself. It doesn't mean that the action is safe from vulnerabilities. It just means that the creator of the action was verified by GitHub somehow. And also the second point highlighted here is I've already mentioned, right? But if you see steps on your actions using calling third-party actions, you're gonna see the uses directive, right? And you can see the actions /checkout. I can find the code for this action that's being called here. I can find going by to github.com/actions/checkout, and then checking the specific version, the v2 version on a public repo, right? These are all public repo. One thing that I did was doing my research there, and was, okay, yeah, can I play around with publishing a malicious GitHub action that's creating a backdoor with a netcat here, and then use another repository and call that action, right? And intentionally in this case, and get that shell, get that backdoor triggered, right? So that's what I did during my research. One of the things, right? So just specifying here, I created a separate repository called fake-gha. This repository is public. You can take a look. But I created kind of my C2 instance was on AWS, was an EC2 instance, right? You can see here EC2 user from the screenshot, and I opened port 443. First, I tried with higher ports, but Azure was blocking, right, the outside connection to higher ports. So I went to 443, and that didn't get blocked. And you can see here that when I run this action on another action, right? So kind of calling that as a third-party dependency. And then I got a shell. I got a shell here. I see the user that's runner. I see the group that it's in. I see also the name of the machine, right? Linux. some name here, and then Azure. So it's an Ubuntu that's running on Azure, but I'm inside my EC2 on AWS, right? So why did I do that? First, because I wanted to try if first the malicious GitHub action attack would work, and second, because usually on the GitHub action you can't type commands to your VM, to your runner interactively. You have to specify that on the YAML script, and then hit it run to let it run and then see the results. So any kind of changes that I made on the script, I had to make the changes on the YAML script and then run it again. Oh, it didn't work. Okay, go back to the script, make some changes, and run it again. So that was getting very annoying and very time consuming. So I said, okay, maybe there is a way to do some reverse shell here so that I can type commands interactively, and that's the way that I found. So here are some of the attacks that I tried and I did work, and I presented that in the article that I mentioned earlier in January. So I was able to run Nmap inside the Azure network there. I was able to do the reverse shell from the runner to an external server, as I showed on the previous slide. And I was able to use this runner. So if I have the backdoor from someone else's runner, I could use that runner to pivot my attacks, right? To target other targets, it's maybe inside Azure, maybe outside Azure, to avoid detection, right? Because the attack would come from the GitHub runner that's associated with another user inside Azure, and I would be able to run scans or collect information or perform exploits from there, kind of hiding the source of my attack, right? So here's just some screenshots of the techniques and the things that I did there and the results. Most of these runners, as I said, they have some idle VMs just waiting to run your jobs. And the first result here is my VM that was running my own action, my own runner, and these are all the ones that I found. Some of the ones resolve the host name, others don't. So I'm not sure they got if they were like responding or valid or what is the kind of decision making here. But you can see that there are some interesting ports here. Besides, 80 and 443, you have SSH open by port 22. You have 3389, which is for RDP. And you have one interesting port here, the 8084. And that's usually maybe web applications using that, and it says web SNP. So I'll leave that port as a curiosity because I talk more about this port and these services that's running on the article. So if you want to know more, just take a look at the article there. But yeah, that's an interesting service that's running by default there, web services, web server. Also, another interesting thing is that the runners, they have Netcat installed, but the version of Netcat installed doesn't have the -e parameter that I needed to do my backdoor. So I had to kind of download from scratch and build from source the Netcat there. So that was interesting. But yeah, just a challenge to bypass, nothing much. But it worked as well, just running those commands here and then getting the backdoor, getting the shell in a similar way. Yeah, the third thing that of course I didn't try that, but it's definitely a possibility, is using my compromised runner from someone else to attack other targets, other servers, other applications, whatever. Right, so I could do that. I was able to do that as well, but I didn't target anyone, just tested. And then I can issue malicious commands from the servers to my runners, right? So scanning another target can be inside Azure itself or outside as well, because I have internet connection to the outside world. And yeah, that was pretty much it. Let me see. countermeasures. Okay.
Sorry, Magno. Costa asks, which can allow you to pin a specific commit version of an action?
Yes. Yeah, I think that this is
Oh,
continuation of a
yes, sorry.
comment. Yeah, you can specify a SHA hash or a version when using the checkout action. Yes. Yeah, technically you can specify pin that. And I think there was a vulnerability on this SHA hash because GitHub was first using this simplified version of the SHA, which is kind of the seven first characters. And another security researcher, was able to generate a collision, right? The SHA hash collision from kind of two different versions of the repository had the same 7 characters of the hash, and now that you have to use the full hash. I can post the link for that research as well, but I found it interesting when I was doing that and finding what was out there. But yeah, Costa is right. Yeah, great information there. Thanks. Yeah, so some countermeasures or some guidance or best practices here for if you're leveraging GitHub Actions already, or if your organization or your client is thinking about doing that. First, yeah, only use actions for trusted creators, right? Make sure that you know the organization and that at least that you understand the code and understand what it's doing. So if you go to the GitHub Actions Marketplace, you can see like how many stars this action has, or how many users it's being used. So there's some kind of popularity measures, which are not really great, but at least it's something to start with when using third-party actions, or you can just use your own actions. So you don't use third-party if you don't want, but it's kind of it defeats the purpose of GitHub Actions. They want to leverage the marketplace, and I believe that's why it got so famous so quickly. But yeah, make sure to set the right permissions to your actions, right? So you have every runner that you run, it has a specific GitHub token, which I didn't talk much about it here, but it has a specific GitHub token that's only valid when the runner is active, and that token can have read and write permissions to your repository, right? So if you don't need write permissions to the repo, you can change that on the settings for your actions in your repository. But yeah, make sure that if someone gets that token, they're able to make changes to your repo while that token is valid, right? So be aware of that attackers may leverage that and try to grab that token. That token is stored inside the runner in clear text, maybe base64 encoded if I'm not mistaken, but I think it's clear text. So you can easily grab that token if you have access to the runner. Do not run actions from forked repos, right? So the first thing the first attack that I described, that was caused by pawn repos, people forking different repos and performing pull requests, right? You have a setting that I'll show on the next slide on GitHub that you can protect that from running actions. Like if that's the first time that this person is submitting a pull request to your repo, you can block actions from running, right? And I can specify that as well. Protect your secrets. There are some secrets that you can use besides the GitHub token. Some actions might require for such things such as API keys for different services. So if I'm using an action from a service that requires a subscription, or at least a user that's registered there to get a token, so I can add that to the runner as well, and that gets stored on your repository and added on the runner. So make sure you protect those. I know that the GitHub tries to mask those secrets from the logs. So if you go to the logs and try to search from them, they're using some masking to encode those tokens, so they don't show up on those logs. But Some of them, if they don't have like a standard format, then they might show up as well on your logs. Okay. Yeah, just a few other sections. So you go to the settings, actions on your specific repository. You have the actions permissions, right? If you're not using actions, I recommend that you disable those. And also the fork pull requests or workflows. Exactly. This was kind of the mitigation that GitHub created. So by default, you can require approval for the first time contributors, right? So if there is a new user, that's the first time that they're sending the pull request to your repository. So you have to require approval to run any actions. So you can specify that as well. And yeah, I guess that's it for content for slides. I'm open for more questions, and if not, I can. If we have more time, I don't know how much we have. I can do some demos. But these are the references, and yeah, thanks everyone for having me, and I'm happy to take more any other questions.
Yeah, that was wonderful.
Yeah,
Great job, man.
Holy hell. Yeah. Anything else that you want to like mention that was not in here, like when you prepared this thing and had to cut like inevitably you have to cut some content because there's a rabbit hole that ends up being its own talk. What was what was that topic for
sure.
you?
Yeah, I think that I'll leave on the references slide, but yeah, two things that I didn't have much time to research on is the command injection via untrusted inputs and how that could affect and compromise the environment via malicious command injection there from those different fields. And the second thing that I tried, but you know that service that I mentioned that's running on port 8084, it's a web server. It's a very old web server. That's I think it's forgot the name now. Let me just look here on my notes. It's a Mono. It's a Mono. She's a XSP web server, and that's on the article as well.
Mhm.
It's not very well known. It's not very well used. It's like a very old web server that was developed on ASP.NET. So I don't know why that's enabled by default there. I'm assuming that's kind of a either like a heartbeat a thing for Azure or maintenance reasons, but I'm not sure why that's enabled by default and the port is exposed there. So those two, I downloaded the code from this the version, specifically the version that was being used on the runner. I downloaded the code. I try to run some static analysis applications, even like SemGraph and CodeQL. I didn't find much. So yeah, I posted all the findings on the blog as well. But yeah, maybe there's something there that could lead to some interesting findings. So if anyone wants to continue this research or wants to go deeper, those are the two things that I would recommend and I'll probably look at.
I'm looking forward to V2 at Sector. I'll be
Yeah.
there.
Sure. Hopefully I have some time to do more research before Sector. Yeah.
We're getting a lot of like super positive feedback about this particular session. As usual, you are a gold mine of information, so thank you.
Yeah, no problem. Thank you.
Matt,
Yeah, how we're doing on time?
But yeah, curious for you. So like GitHub Actions is kind of like a service that you would probably by default just assume it was kind of relatively safe, and you weren't going to have like these crazy exploits going on in them to basically run crypto miners and stuff like that on your own infrastructure. So what do you think about that? Like, I guess that's like it's an interesting concept, right? Just like it's kind of like re-examining areas you thought were safe in your own environment, and it's a whole rabbit hole, right? Like,
yeah. So when you're running your action, think about that runner as your own server, right? You pretty much have root permissions inside that server, but it's like you're running in an environment that's shared with other users, right? So you have different VMs and what happens, like if I'm inside a runner that I compromise and I can attack other runners, maybe, like that's also something that to look at, right? Is the network properly protected? But yeah, that's kind of, I even thought this from this research, like I even went to the GitHub kind of bug bounty platform to see
Oh
if
yeah,
anything was eligible for a bounty or something. But this is kind of the how the system is designed for the
Intended.
GitHub Actions is intended, right? So it's supposed to have, you have free access on that runner, but yourself from your user, right? For compromising another user, that's the situation of the that I tried and I proved there on the malicious GitHub action, right? So I didn't publish the action to the marketplace, of course, but if I had published that and I labeled this as a interesting feature and kind of encoded the malicious part of the code, hiding the malicious part, then I would probably get some hits and kind of callbacks to my C2 server there. So yeah, just be careful with the third party actions and kind of what you're using. It's there is a lot of stuff there, so you don't need to reinvent the wheel, but you know, take a look at the other actions that you're calling, because this is code that you're downloading from someone else and running in basically your server, right?
Yeah,
Although
no, very true,
yeah,
very true. So also,
The
does this
basics
so
of supply chain. Yeah.
yeah,
yeah, of course. So this particular vulnerability, like I know we talked about like third party actions and stuff like that, right? But
mhm.
obviously other platforms, I think you may have went over this already. So sorry, this is like a duplicate question, but like
No
other
problem.
platforms also have their own like what is effectively actions, right? So like stuff like GitLab has their own version. Would just be something that would be also affecting users in GitLab, or is it like functionally different?
Yeah, so GitLab, this is a problem that's common to any marketplace, right?
Hmm.
But GitLab, I don't think GitLab has a marketplace. You have to have your own Docker image to run your GitLab CI. So if you have control and if you trust that Docker image, right, then you can run your automation. So it's a similar approach, but the difference is that GitLab doesn't have this marketplace where anyone can publish and share their actions and anyone can use that. But yeah, similar thing with Jenkins plugins, right? If you're using a plugin from Jenkins, just be aware of those, the version and where is it coming from. If it's trusted, keep them update. If you saw that, oh, some actions have different versions. Sometimes I was calling V1, sometimes calling V2. So make sure that you're calling the right version and the most updated one. What else?
I guess it kind of goes back to what you said about like you just kind of have to treat them as like third party dependencies, right?
Exactly, right. And I see that that was kind of a idea that I had in my mind while I was doing this research. Okay, what about a scanning tool, right, to scan those YAML files from GitHub Actions and check the third-party dependencies and at least kind of assess them for a specific risk, right? Are they trusted or not, or where they're coming from? But I believe that GitHub is working on that already. They have CodeQL rules and scanner for these Git actions. I'm not sure if they're looking for the third-party dependencies and kind of risks, but yeah, I know that they're doing some work there already.
Yep.
But yeah, just like a software composition analysis, you could have a software composition analysis for GitHub Actions.
Mm-hmm.
Yeah.
There was a question, I think a speculative questions from Costa about, he asked, did you do any analysis of self-hosted runners? And the comment is, I guess not, since it's your VM instead of GitHub hosted one. But
Yeah, exactly, right? Self-hosted runners mean that you deploy the VM and then you can run that anywhere. You can run on Azure or AWS or whatever. So if you're not trusting the VM that you're building and deploying, then it's like, okay, yeah, they can be compromised. So I didn't do any analysis on self-hosted runners, no.
okay. And then I think
Yeah,
there was a question that was answered by another
mhm.
person in the chat too. So
Yeah. Can you run your actions inside your own VMs? Yeah, these are the what called the self-hosted runners.
yeah.
Yeah,
And then so
exactly.
Complete side tangent, by the way, but it's kind of funny when you put the little comment thing above. I feel like I'm like Mike Wazowski in like Monsters Inc. You know, he gets on like the little poster. And he gets so fun.
Actually, I
But
love
yeah,
the feature about streaming your
I saw that you posted the 2 repos that I used for my research. So the GHA/test, that's the one that I use for mainly all the testing that I did. And I think the logs, I'm not sure if they stay there for 90 days, but you can look at the commit history of all the changes that I made and everything that I tried. If you want to look at the research that I did, it's all there. And the fake GHA was exactly this, intended as a fake GitHub action. This was the one that I used to create the backdoor, and it was basically a shell script installing Netcat and then connecting back to my instance, which is not available anymore. So yeah, it's there, but you can take a look if you want to try other things as well. Feel free to just look at that and see what I did. And if you want more information about those, feel free to reach out to me.
Awesome. And if someone was like interested in learning about more about like what you do at your job and potentially working on your team, like where should they go?
Reach out to me on either LinkedIn or Twitter. It's Magno Logan on both. That's where I'm more active. But you can take a look at the careers, the job available jobs for Canada. We have over, I think, 20 positions, not just for security, but developers and product managers and all that stuff for either Montreal, Toronto, and Ottawa offices. I know that we have some security positions for Ottawa and Toronto. And it's like researching positions. So it's either doing a similar job that I'm doing, or either helping us with creating signatures and rules for our products, right? We have IPS and different other products, so creating rules for that. But just reach out to me and I'll talk more about it. I don't want to give too much information here. It's not
Yeah, of course. Awesome. And I think Costa had another great question, which is how long did it take to perform this analysis? Did you just set the workflow to on push and then try again and again and again?
Yes, exactly. That was the first. So it took about 2 months. Of course, I got frustrated and then changing the commands and then start using the backdoor that I established. I used that as an interactive shell. So if I didn't need to restart the runner and create a new one, then I could just issue commands that directly with my backdoor. But if not, then yeah, just trying again and again and again. Yeah, it's basically that. It's
awesome.
That's research, right? You try and you fail, then you try something else, and yeah, it can be frustrating, but yeah, I like it.
No, of course, that's it's quite interesting to hear any sort of insights to like the research side of things. That's beyond me completely, but
yeah, cool. And that's exactly what I described in my blog, right? The one from January 18th. Yep. It's like I tried many different things. Here are the things that didn't work, and here are the things that worked. So it's like I try to be very thorough in like how I did my research. It's not just like the end result. It's not like, oh, I'm not just trying to embellish or trying to fluff it up, right? So I make, it's only pretty things and everything is magical and in security. No, there are many things that I tried, many things didn't work, and here are the stuff that worked, right? We have to be honest about it. So yeah.
Of course. And your blog was KatanaSec, I believe, right?
KatanaSec.com, yeah. I think there is a issue with my certificate that I need to update, but I'll do that as soon as I can.
Yeah, of course.
As you were talking, I was just thinking like, oh, you mean security is not like the like hacking is not like the movie montages where
exactly.
You just, and then everybody's in. It's like hours and hours and weeks of staring at something and banging your head against something.
Yeah. Was 2 months at least doing the research, and then 1 more month to write the blog post and review and add all the evidence and everything, right? So yeah, it was very long research.
I guess it was worth it.
Sure, for sure, yeah. Just to be here, it was worth it.
Oh yeah, no. Yeah. It's a special place here at OWASP Toronto.
But yeah,
Perfect.
hopefully I see anyone that's watching the presentation or anyone here on this call in sector later this year. I'll probably be there in person, and I'll present probably some new things. It won't be totally new. I'm pretty sure there are some things that will be the same, but I'll try to bring some new content regarding this research for sector.
Awesome. I think we're going to be at Sector too, so I guess we'll
Yeah.
see you there.
Sure, awesome.
I think there's a request in the chat for the slides as well. So usually we do have slides for this and we post it back up in the meetup as previous things. But like, given that you're going to give this again at Sector, did you want to hold on to the slides or did you want to like publish a version, or what's your thought, Magno?
I don't have a problem with sharing the slides. Maybe I'll just kind of blur some of the URLs there for the GitHub, but it's also on the recorded version. It's not a problem, but yeah. But yeah, just to try to have something. But I'll definitely share the slides. It's not a problem for me.
Awesome. Thank you, as usual. I think things have trailed down a little bit in terms of questions. Anything else you had questions about, Matt? Anything else anybody wanted to comment about?
No, I think you answered all the questions. You did a really good job like explaining your thought process as you went through the presentation. So I think naturally that leads to a little bit less questions overall when you do a good job. So
hopefully,
yeah, good.
Awesome. But yeah, thanks again for having me. I'm happy to come anytime if you want to talk about Kubernetes or anything related to cloud native, containers, all that stuff. I'm always open to share and yeah, just talk about this stuff.
Awesome.
We will totally take you up on that because every time I learn lots. So
it's my favorite bar talk is Kubernetes containers. Yes.
There's so much.
Yeah.
Awesome. Cool. I think we're good with that, right? So
yeah.
Any final words from anybody? I just want to say, do you want to say goodbye, everyone?
Yeah, thank you very much for coming again. Really appreciate that. For the audience, we'll be figuring out our July speaker, and so please tune in again next time. From a housekeeping perspective, again, if you do have comments, questions, concerns about the talk, you can reach out to Magno. And if you have any comments, questions, concerns about how OWASP Toronto chapter is doing, please use the feedback link, or you can email us too. Right. That's pretty much it. And so much thanks to our global OWASP sponsor. I think we have a brand new one too. So yeah, we just got sponsorship from Packet Labs. So
nice.
Right.
Thank you everyone.
Thanks to them. And that's pretty much it. Okay. Well, awesome. Thanks again. Have a good night, everyone.
Bye.
Thank you, sir.